We are moving forward to Chapter 12, Section 6, and just a quick review of what we've been doing. If you have something like m squared n over m n to the fourth, there is no pluses or minus linking anything, so anything cancels. There's two m's on top, one m on the bottom, which means there's one m left on top. One n on top, four n's on the bottom, which means there's three n's left on the bottom. So this would simplify to m over n cubed. If you want to go ahead and pause this and do these problems and then just fast forward and check your work, it would be a great idea. So 2 over 6 is 1 over 3. 3x's on top, 1x on the bottom, 2 left on top. 2y's on top, 1 on the bottom, 1y left on top. So x squared y over 3. Number 3, we have on the top 3a plus 6a squared. On the bottom, 3a squared b. Now the top is linked. We can take a greatest common factor out of that, which is 3a, and then we'd be left with 1 plus 2a. Now that the greatest common factor is out front, the top part that you took out does not have a plus, so we can cancel the 3's and we can cancel one of the a's. So our final answer is 1 plus 2a over a b. And the next part is factoring the long way. So there's not a greatest common factor to take out. 5 times 12 is 60. Two numbers that multiply to give you 60x squared, that add to give you 16x. Are 6 and 10. So I'm going to rewrite this as 5x squared plus 6x plus 10x plus 12. Now I'm going to do this two different ways. One way with the box, and with the box we need to figure out on the outside what each term needs to be. So if this is 5 right here, and if this is 10 right here, this is probably going to have to be the 5x, which leaves this being the x. So this is 10, which means this part up here would have to be 2. So now we get our 10 and our 5x squared, which means this would have to be 6, and everything works out. So our factored form is x plus 2, 5x plus 6. Oh, okay. Now, if you just write it out, you can group the first two and the last two. It doesn't matter the order that you write it. And then you take the greatest common factor out. In the first part, the greatest common factor is x, left over with 5x plus 6. In the second part, the greatest common factor is 2, left over with 5x plus 6. So now we would take the 5x plus 6 out, and then we would be left over with x plus 2. X plus 2. So that's our answer. Either way. Both ways are phenomenal methods. Alright, the next problem, it looks like we have perfect squares going on here. This is 4p times 4p. This is 9 times 9. Is the middle term 2 times the first times the last? And it is. That means our answer is 4p minus 9 squared. I would probably write it out like this, and it's always a great idea to check by distributing. All right, today's topic is long division of polynomials. So, all right, we're going to divide this out by doing 8p cubed minus 4p squared plus 12p all over negative 4p squared. So So the first step is to take out the greatest common factor because the whole numerator is linked. So that would be 4p. And once we do that, we're going to have a 2p squared minus 1p plus 3. Now, this is completely linked, but I can cancel this business out front. So the 4 cancels, and I'm going to put a 1 just so I don't lose that negative right there. And the p's will cancel, giving me 1 left on the bottom. So my simplified version is 2p squared minus p plus 3 all over negative p. Now, since there's only one term on the bottom, this can be rewritten with each individual term being divided by negative p. And we can simplify this to negative 2p because the p's cancel and we've got the negative. We can simplify this right here to 1, and then we've got the 3 over the negative p. So this is actually a slightly simpler version of this. There's another method called long division, and that's what this unit is about. So if I do 8p cubed minus 4p squared plus 12p, and then if you divide by negative 4p squared, we're trying to figure out how many times does negative 4p go into 8p cubed. So negative 4p squared times what gives 8p cubed? And that'd be negative 2p. So when I multiply negative 2p times negative 4p squared, I get 8p cubed. And then with long division, you subtract and get 0. So now I'm going to bring down my negative 4p squared, and I'm thinking negative 4p squared times what gives me negative 4p squared? That would be 1. So I get negative 4p squared, and then you subtract the whole thing, and then you bring down your 12p, and negative 4p squared times nothing gives 12p, so my remainder is 12p, so I'm going to do plus 12p over negative 4p squared. Now that part simplifies to this 3 over negative p, so as you can see, this answer right here is the same as this answer right here. Alright, let's try to do that long division method with the next one. 6x squared, cubed. I'm going to put in an x squared term being 0. Actually, I'm going to. I don't have an x squared in this equation, so I'm going to put one in just because I like to hold every spot. So see how it goes, x cubed, then x squared, then x, then no x's. And we're dividing by 6x. Okay, 6x times what is 6x cubed? That'd be x squared. So x squared times 6x squared is 6x cubed. When we subtract that, we get 0. So now we're going to do the 0x squared, which is nothing. That'll be more important in the future. Now we're going to figure out 2x times what gives 6x. That would be 3. That would be 1/3. So that would be 2x, and then when we subtract the whole thing, we get nothing. And then 6x times what is negative 15, and that is nothing. So our remainder is a negative 15, but then that's over this initial 6x. So that's what we get through long division. If you want to look at that individually dividing, we would have 6x cubed plus 2x minus 15 over 6x. So we can break this up, 6x cubed over 6x, 2x over 6x, negative 15 over 6x. This is just one more method. Every single method works the same. So this first thing cancels to be an x squared. The second thing cancels to be a 1/3, and then the third thing is just what it reads. You could also do the greatest common factor method. So that's dividing out. Now, the weirdness comes in when you're dividing by a binomial and it's not factorable. So these are all factorable. Let's just do them really quickly. I'm going to rewrite this as k squared plus 7k plus 10. So that factors into k plus 2, k plus 5. So the k plus 2's cancels. We would be left with k plus 5. This next one is the difference of squares. So it's b plus 7, b minus 7. The b plus 7's cancel, so we'd be left with b minus 7. And then the last one, this is perfect squares. So s plus 6, s plus 6. One of the s plus 6's cancel, so s plus 6. Now, I'm just going to show you one with long division because the next step we will do where there's not a remainder, and that's where you have to use long division. So we have k squared plus 7k plus 10. And you do need to have this in order, so the squareds first, then the singles, then the no letter. And I'm dividing that by k plus 2. So the first thing I'm looking at is my k right here. And k times what gives me k squared? That's k. Now I'm going to take this and I'm going to multiply this k by this k plus 2. So I get k squared plus 2k. Now when I subtract this whole thing, the first thing will always cancel. It has to. We made it cancel, making that k. And then 7k minus 2k is 5k. Then you bring down the 10. So next I'm trying to see k times what is 5k? Well, that's 5. Now I'm going to multiply the 5 through to the k plus 2. 5 times k is 5k. 5 times 2 is 10. When I subtract the whole thing, I have no remainder. So this is my answer. This I know is my answer. I'm going to, I guess, well, this one factors also. I guess we'll just try this real fast. Okay, so x times what gives x squared? And that's x. So now we have x squared plus 2x. Subtract the whole thing. This is gone. We get 1x. Bring down the 2. X plus x times what is x? That'd be a plus 1. 1 times x is x. 1 times 2 is 2. When we subtract, we have nothing left. So that's what you get when you divide those two out. All right, the next problem now is the same thing, except this first part, this 2x squared plus 3x minus 6, is not factorable because the two numbers that multiply to give negative 12 that add to give 3 don't exist. So this is where you have to use long division, and long division is your only option. X times what is 2x squared? And that would be 2x. So now I'm going to multiply this out. 2x times x is 2x squared. 2x times negative 2 is negative 4x. We subtract the whole thing. This is gone. 3x minus negative 4x is 7x, because minus a negative is plus a positive. We're now going to bring down the minus 6. X times what is 7x? That would be 7. 7 times x is 7x. 7 times negative 2 is negative 14. Now we subtract the whole thing. This is gone. Negative 6 minus negative 14 is 8. x does not go into 8, so this is our remainder. So we're going to put plus, because it's a positive 8, and then it's 8 over x minus 2. This is my answer to what I get, what you get, what we all get when you divide these two things. So if you were to do 2x squared plus 3x minus 6 over x minus 2, there's no way to do that because this is linked and this is linked, and you can't go putting anything over the links because you can't break them up. So it's impossible to do it this way, which is why there's long division. Let's try another. So 3m squared plus 4m minus 2 divided by m plus 3. M times what is 3m squared? That would be 3m. When we multiply that out, 3m squared plus 9m. When we subtract, we get negative 5m. Bring down the negative 2. M times what is negative 5m? Negative 5. Negative 5 times m is negative 5m. Negative 5 times 3 is negative 15. I did plus a negative. Okay, so when we subtract the whole thing, negative 2 minus negative 15 is 13. So it's a positive 13. So I'm going to put plus 13 over m plus 3. One more. How's that grab you? Maybe 2 more. All right. The first step is to put these in order. So I would put negative 4x cubed. This is when I will put my 0x squared placeholder. Then my plus 3x, and then minus 15. Long dividing with 2x plus 3. 2x times what gives negative 4x cubed? That's a negative 2x squared. Negative 2x squared times 2x is 4x cubed, negative. Negative 2x times 3 is negative 6x squared. Subtract the whole thing. 6x squared, bring down the 3x. We're getting a positive 6 because a negative negative is a positive, minusing a negative. All right, 2x times what is 6x squared? That'd be 3x. 3x times 2x is 6x squared. 3x times 3 is 9x. Subtract the whole thing. Negative 6x. We're now going to bring down the 15 negative. 2x times what is negative 6x? And that'd be negative 3. Negative 3 times 2x is negative 6x. Negative 3 times 3 is negative 9. Subtract the whole thing. And we get negative 6. So I would put minus 6 over 2x plus 3. You could put plus as long as you make the 6 negative. This is your answer for what you get when you divide that trinomial by the binomial. I think we have time to do the last one. Again, these need to be put in order. X cubed plus negative 4x squared. Don't be losing that negative. My placeholder of a 0x plus 1. Long divided by x minus 2. X times what is x cubed? That'd be x squared. That gives us x cubed minus 2x. Subtract the whole thing. Negative 4x squared minus negative 2x is a negative 2x. Bring down 2x squared. Bring down the 0x. X times what gives you negative 2x squared? That's a negative 2x. So negative 2x squared and a positive 4x. This is why we need that placeholder. We're going to subtract the whole thing, and we get a negative 4x. Bring down the 1. X times what gives negative 4x, and that's a negative 4. Negative 4 times x is negative 4x. Negative 4 times negative 2 is positive 8. Subtract the whole thing, and you get negative 7. So I'll put plus negative 7 over x minus 2. And that's your answer. Okay, well, hopefully that made a ton of sense, and tomorrow's work will be easy. Have a great night.